Question number 11. A constant head test was conducted on a sample of soil 15 centimeter long, so this is the dimension of the sample. And what about the cross-section area? Is 60 square centimeter. The quantity of water collected was 40.5 cubic centimeter in 15 seconds. So this is capital Q and this is the time. So if we divide Q by the time, we will get the discharge rate, which is small q. And they said we collect this amount of water under a head difference equal to 24 centimeter. Okay, now I ask you to calculate the hydraulic conductivity, and if the porosity of the sand were 0.55, calculate the discharge velocity, which is the Darcy velocity, and seepage velocity. Then estimate the hydraulic conductivity of a similar soil but with different what porosity. Now the porosity here is equal to 0.35 for this test. This is a very simple test. I should go to the formula sheet, and here we have the hydraulic conductivity section. Which equation that I'm going to use from here? This is really very important question. So which equation representing the case of the constant head permeability test? This is the equation which is representing this case. Q is given, T is given, what else? L is already given, H is given, and A is already given. Okay, so we have all of this information, so simply we can calculate what? We can calculate the hydraulic conductivity of this material. So this is the first requirement here. Now he asked me if the porosity of the sand was this value, calculate the discharge velocity and seepage velocity. Simple. Now, why? Because we know that the velocity is equal to what? The velocity is equal to hydraulic conductivity times I. What is this velocity? Is the discharge velocity. Okay, I know already what is hydraulic conductivity. What about I, which is the hydraulic gradient? The hydraulic gradient is equal to what? Hydraulic gradient will be equal to the change in the head, which is already given here, which is 24, divided by the distance, which is this 15 centimeter. So now we will have what? We will have the gradient. So now I can get easily the seepage velocity. The discharge velocity. Okay, now if we want to get what? If we want to get the seepage velocity, what we should do? We know that seepage velocity, let us call it Vs, is equal to what? Is equal to V, which is the discharge velocity, divided by N, which is the porosity. So simple and easy. We were able to what? To answer these two part of this question. Okay, now the third part here said estimate the hydraulic conductivity of similar soil but with different what? Porosity from this result. Okay, I think we all remember this empirical equation, okay, that we have, and how we use it before in some example to determine the hydraulic conductivity at certain porosity by knowing the hydraulic conductivity at one porosity. Just to refresh your memory, we have this example that's already available in the formula sheet, and we use either Casagrande equation or Taylor equation, and we were given the hydraulic conductivity at certain porosity, and we were able to determine what the hydraulic conductivity at different porosity. So if you go to the lecture notes and review this example, definitely you will be able to solve this part of the question. Thank you very much.